So in our last class, we have already defined what is probability and some properties of probability, and also we have discussed some standard examples like coin or die or cards, and how to calculate probability based on such situations, right? So today we are going to study another kind of probability which is very important in real life, which is called conditional probability. Right? So we are going to focus on conditional probability. Now, what is conditional probability? The conditional probability of occurrence, so the definition is the probability of occurrence of an event A. So let's say we have two events A and B, right? And the probability that A happens only if B, the event B, has already happened, is called probability or conditional probability of A, right? So the probability of occurrence of an event A given that the event B has already occurred is called conditional probability of occurrence of the event A. And how we denote it? It is either denoted by P A B or P A slash B. Both of them are same. So in some textbook or in some exercise you may find this symbol. In some textbook or in some exercise you may find this symbol, but they ultimately mean the same. So the meaning of this symbol P A B is called probability of A given B, right? So we call it as probability of A given B, and the meaning is this event called A only happens if the event called B has already happened, right? So let's say probability of appearing in HS examination given the person has passed in HSLC examination. So in that case, B is HSLC, A is HS. So B already occurred and we are interested in A, right? So that is probability, conditional probability of A. Similarly, if you change the rule, that means if you are interested in the occurrence of the event B, given that event A has already occurred, then it is called conditional probability of occurrence of event B, and we will denote it by P B given A, right? So P B given A. P B given A will give you the probability of B given that event A has already occurred. Now, what is the formula to calculate them? The formula to calculate conditional probability of A given B is probability of A intersection B divided by probability of B, right? Similarly, the probability of B given A is equal to probability of A intersection B given probability of A, right? So we have the structure is same, the numerator will be same, probability of A intersection B. The only thing that differs is the denominator. If you are finding out the probability of A given B, so the event that already has occurred here, B have already occurred, so probability of B in the denominator. Here probability A, the event A has already occurred, thereby probability of A, right? So this is the structure, probability of A given B. Okay. So there is one single property that is associated with this concept, and that is if A and B, if the event A and B are completely independent, then it does not matter whether A B has occurred or not, it is same, right? So if A and B are independent, in such a case the conditional probability reduces to the simple probability, right? So what does P A given B means? It is a probability that A occurs given that B already occurred. Now if there is no relationship between A and B, then it does not matter whether A B occurred or not, it will remain the same. So that's why we can write probability of A given B is equal to probability of A only if A and B are independent, right? And in such case, if we place the value, if this become probability of A, then what happens? Probability of A is equal to probability of A intersection B probability of B. So we can write probability of A intersection B is equal to probability of A into probability of B, right? So this is the property associated with conditional probability. If the two events A and B are independent, then we can write this expression. That means A intersection B. Now what is A intersection B? A intersection B represents the probability of simultaneous occurrence of A and B. That means A, B both happens at the same time, right? So we can write this expression. Now let us try an example which will clear us the idea of calculating conditional probability. So in this example, we are given that probability of happening of the event A is half, probability of happening of the event B is 1/3, and the simultaneous happening, that means A as well as B is 1/4, right? And we are supposed to find out what is the probability. Now this is P A given B, that means conditional probability of A subjected to the condition that B has already occurred, right? And this is probability of B given A, that means probability of B given that A already happened. So we are going to calculate these two quantities. Now the solution is, right? So we will calculate, let me go back to, now the solution will be, we are given that probability of A is 1/2, probability of B is 1/3, and probability of A intersection B is equal to 1/4. So now to calculate probability of A given B, what is the formula? The formula is probability of A intersection B, probability of B, right? This is the formula of calculating your conditional probability of A given B. So to calculate this, we need two quantity. First quantity is probability of A intersection B, which is 1/4, right? And what is the second quantity? Probability of B, that is 1/3. So the ultimate value is 3 divided by 4, which is 0.75. Now at this point you can leave the answer as it is, 3/4, or you can express it in terms of decimals also. A fraction value or a decimal value, both are correct, it does not matter. So ultimately the probability of A given B is 0.75, right? So this is how we calculate conditional probability. The next one that we have to calculate is probability of B given A. Now the formula for this is, as I said, the numerator will be same, probability of A intersection B, and the denominator in this case, since we are calculating probability of B given that A, so it will be probability of A, right? A simple way to remember is, your numerator will always be A intersection B, the denominator will be the one that is written next, right? So probability of A, so this is equal to probability of A intersection B is 1/4, and this is 1/2. So this gives us 2/4, which is 0.5, right? So we are done with this example. The next example is, find the probability that there are 2 boys in a family of 3 children, given that the eldest is a girl, right? So we have to find out probability that there will be 2 boys in a family of 3, right? So in a family of 3 there are a lot of combinations, right? All can be boys, all can be girls, so there are different combinations, and we will try to find out what are the different combinations, and out of that we are interested in finding out the probability of getting 2 boys. Now it is subjected to the condition that the eldest is a girl, right? So let's try to calculate this. So in this, the solution will be, let A denote so let A denote the event of getting two boys, right? B denote the event that the eldest is a girl, right? So we have two events, we have denoted that. Now we are interested in finding out the probability of getting two boys given that the eldest is a girl, right? We are to find probability of A given B, right? This is what we are trying to find, probability of A given B. Now how to find this? To find this, we will have to calculate probability of A intersection B. Now what is the value of this? We know probability of A given B is equal to probability of A intersection B, right, divided by probability of B, right, divided by probability of B. So we need this, we need these two values. If we can get probability of B and probability of A intersection B, then we can calculate probability of A given B. Now what is probability of B? Probability of B is probability of the eldest being a girl, right? So we need to find out what is the probability that in that family the eldest will be a girl. And what is A intersection B? It is the simultaneous occurrence of these two events. The eldest will be a girl and there will be two boys, right? So to find out probability of A intersection B and probability of B, we will have to first, in like any other calculations of probability, the first thing is to write down the sample space. So we will write here the sample space is. Now in this type of question the way we write sample space is as it is how many, we have 3 children, right, and each of them has the possibility of either being a boy or girl, boy or girl, boy or girl. Now if you multiply this, you will get the ultimate sample space. If I multiply this B by B, so I will get B, right, comma B, G, G, B and G, G. And last one is B comma G. Now if you multiply all of them, you will get the ultimate B, B, B. So I am multiplying this by this, B, B, and then B, B, that means boy, boy and girl. First boy, second boy, third boy, all 3 of them are boy. First 2 are boy, the last one is girl, right? Next we will get boy, girl, boy, right? Next we get boy, girl, girl. Okay. Next we will get girl, boy, boy, right? Next we will get girl, boy and girl, and the last two are girl, girl, boy, girl, girl, and girl. So this is the sample space. This is our sample space. Now we are interested in A and B. What is A? A is getting 2 boys. So I will use green for A, right? This will be A, and I will use blue for B, right? So B is denoting eldest is a girl, the first child is a girl. So what are the blues? This one is a blue, this one is a blue, this one is a blue, and this one is a blue. So the blue box represent that those events or this condition satisfies our event B, right? The eldest is a girl, right? Now I will use green to denote A, getting 2 boys, right? Huh? 2 boys. So 2 boys, this is an event of 2 boys, right? This is an event where also we have 2 boys. There are 3, but it is greater than or equal to 2. This is an event where we have 2 boys, right? Then this over here is an event where we have 2 boys. Okay, so these are all the events where 2 boys condition is satisfied. This one, this one, this one, and this one. There are 4 conditions which satisfy our, or 4 situations which satisfy the condition that there will be 2 boys, right? So now we will calculate probability of B and probability of A intersection B, right? Now what is A intersection B? A intersection B is the simultaneous occurrence of both getting 2 boys and the eldest is a girl. So see the box which have both green and blue, this box over here, this box over here has both green and blue. That means it satisfies both condition A and condition B. So that means we have only one situation, only one favorable case where we are getting 2 boys as well as the eldest is a girl, right? So this is the favorable case for A intersection B, right? And what is B? B being the eldest in a girl. So all the boxes with blue circles, these blue rectangles, are favorable for event B, right? So I will write it down. Okay. Favorable cases for B. And what was B? Eldest is a girl. So what are the favorable cases? Favorable cases will be girl, boy, boy, girl, boy, girl, 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 boy, and girl, 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 right? These 4 are the cases which are favorable for the event of getting the eldest as a girl, right? Therefore probability of B will be how many numbers? 4, right? And what are the total number of cases? The total number of cases was 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total number of cases, out of which 4 are favorable for B. That means 4 divided by 8, right? So probability of B is half, right? Next we have favorable cases for A intersection B are, now what is A intersection B? A intersection B is we are getting two boys and the eldest is a girl. So obviously this is the only possibility, two boys and eldest is a girl. So G B B, right? So therefore probability of A intersection B will be, there is only one favorable case, so it will be 1 divided by 8. Why 8? Because total number of cases is 8. So we got A intersection B as 1 by 8, probability of B as half. So the result will be, therefore probability of A given B is equal to probability of A intersection B probability of B, which is equal to 1 by 8 divided by 1 by 2, right? So this gives us so this will gives us 2 by 8, which is 1 by 4, which is the answer for this question. So what is the probability? That there will be two boys, given that the eldest will be a girl, the value is 1 by 4, that is 1 out of 4 we have that particular chance, right? So the next example is example number 6. We are given probability of A, probability of B, which is a unknown quantity X, and probability of A union B. We have three values. Now we have to find out for what value of X, A and B are mutually exclusive and independent. So before solving that, let's recap when two events A and B are called mutually exclusive, when they are called independent. So two events A and B, right, these two are will be called independent if A intersection B is equal to probability of A intersection B is equal to probability of A into probability of B, right? This is condition for two events A and B to be independent. If their simultaneous occurrence is equal to their product, then they are called independent. And mutually exclusive if probability of A intersection B, that means their simultaneous occurrence is equal to 0, that means it is impossible, right? Now what is mutually exclusive? When two events cannot occur, right, then their probability will always be 0. So these two conditions, and using these two conditions we will find out the value of X for that particular situation. So solution number 1, we are trying to find out mutually exclusive. So for A and B to be mutually exclusive, probability of A intersection B should be equal to 0. Now in the question we are only given probability of A, probability of B and probability of A union B, but we have nothing about probability of A intersection B. So in that case what we can do, we know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is the relationship. Now we are trying to find out for what value A and B will be mutually exclusive. Now if they are mutually exclusive, probability of A intersection B should be equal to 0, right? So under this condition, from this relationship we can find A union B is 0.7, probability of A is 0.4, probability of B is X, and this is obviously 0. So this gives us X equal to 0.3. So if X is equal to 0.3, A and B are mutually exclusive, right? So that solves our first question. Next question is number 2 is when they are independent. So number 2, for A and B to be independent, probability of A intersection B should be equal to probability of A into probability of B. This condition should be satisfied. Then here we can modify the calculations, right? So here we can modify the calculation. How we can modify? Here probability of A union B is 0.7 equal to probability of A, or let me write down the expression first. Probability of A union B equal to probability of A, probability of B. Now if they are independent, we can express their simultaneous occurrence, that means intersection, as the product, right? So minus probability of A into probability of B. Now this value is 0.7 is equal to, what is probability of A? 0.4 plus probability of B is X minus probability of A is 0.4 into X, right? So solving this will give us the value of our X. So to solve this, I will transfer this here, so it will be 0.3 is equal to 1 minus 0.4, that means 0.6 times of X. So this gives X equal to 0.3 by 0.6, which is, I guess, half. So X equal to 0.5. So for this the answer is 0.3, for this the answer is 0.5. So this is how we solve this situation. Now there are certain questions where they will ask you to find out whether the events are mutually exclusive or independent. Now how you will do? You will calculate them, and if you find out that the intersection, probability of A intersection B, can be expressed as their product, then you will say that they are independent. If it is exactly equal to 0, then you will say that they are mutually exclusive, right? And the next question is, we are trying to find out the probability of getting 2 or more heads consecutively given that a coin is tossed 3 times, right? So we are trying to find out the probability of getting 2 or more heads, right? So here the solution will be, what will be the solution? First you will have to write down the sample space, right? So what we are tossing 3 coins together, 3 coins, 2 outcomes, 3 coins, so 8, right? I have shown you the formula in our previous lecture, where this is the number of outcomes, here number of repetition. So here a coin is tossed 3 times, every coin is supposed to get 2 outcomes repeated 3 times, so total number of outcomes will be 8. And what will be the outcomes? The outcomes will be head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, and tail, tail, tail. These are the 8 possible outcomes when you toss 3 coins. So this is our sample space. Now what we are interested in, finding the probability of getting 2 or more consecutive heads, right? So let's say A denotes the event of getting 2 or more consecutive heads. So what will be the set? Two or more consecutive heads. Consecutive means one after the other. So I will denote them or circle them by red. This one satisfies the condition, two or more consecutive. Here also we have two consecutive heads, right? Here also we have two consecutive heads, and we have none other, right? We don't have any other where we have two or more consecutive heads. All of them has it, though it has two heads, but they are not consecutive, right? So we have three possibilities. So I will write head, 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 tail, tail, head and head, right? So we have three favorable cases. Therefore probability of A will be 3 by 8. Why 8? Because we have 8 number of total cases, we have 3 favorable cases, that's why 3 by 8 is the required probability. Okay, so this is all about this lecture, where we have studied what is conditional probability. We have also discussed how we can calculate conditional probability, and we have also discussed some other examples of probability, how we can calculate probability in some other situations also. So this is all for this one. In the next one we will discuss about some standard probability distribution. In your course you have 3 or most commonly used distributions in biostatistics are binomial, Poisson and normal. So we will discuss those 3 distributions in our next one. So that's all for this one. See you in the next one.